The SciComm Collective acknowledges the Whadjuk people of the Noongar Nation as the traditional custodians of the lands we study, write, and record on, and their sovereignty was never ceded. Hello, and welcome to the SciComm Collective.
Different useful knowledge in different areas.
The joy is sharing it, making science accessible,
The ignored final step of the scientific method.
every different perspective.
Science is culture.
The SciComm Collective, bringing science and science communication to you.
Hi everyone, welcome back to another episode of Summer Shorts, brought to you by the SciComm Collective. My name is Felice, I'm doing a minor in science communication, and today I'm joined by Keelan Powell. Welcome, Keelan.
Hello.
So before we get started, could you tell us a little bit about yourself and what brought you to science communication?
So I've always been a creative writer. I've written multiple books, but in high school I was kind of generally pushed towards science because I was very good at it. So I ended up doing a physics degree.
Nice.
And was bored
Oh,
for 4 years. So 4 years of just absolute boredom. Because in all my assignments, I tried to be kind of narrative with the information that I was writing, and they were just like, please don't.
Yeah.
And so I went, okay, fair enough. But then I talked to some people, including people in physics, and they were like, hey, you should try going into science communication because that might work better for you than staying here and doing physics, where you're kind of boxed into this particular way of writing, which is essential for physics because physics gets very complicated, and so you need to word things in particular ways, because if you don't, other people in the field aren't going to understand what you're saying. And, kind of important that other scientists understand what you're saying. After a year of working in analytical chemistry labs, I ended up in the Master of Science Communication.
Awesome. And you've just recently graduated last year, but as part of your master's, one of the units that we all had to take was science presentations.
Mm-hmm.
And how'd you find that unit? You mentioned that you're more of a creative writer, so was it challenging for you to do more of like a presentations type of unit?
So I enjoyed it. I enjoyed it actually because in that year where I was working in analytical chemistry labs, on the side I was also making YouTube videos. So I made one video that was like 40 minutes long that was just entirely about how to make a fictional planet as realistic as possible.
Very cool.
And so I had some experience editing videos already, but this really, it taught me a lot about all the things I've been doing wrong to start with. So that was good.
Yeah.
But it was also it was a lot of fun to get to really get into the nitty-gritty of actually making short videos, especially short videos. For me, that was definitely what I struggled with the most, was keeping things short. Because like I said, 40-minute video on how to make a planet, as opposed to you've got a 5-minute video and a 3-minute video in science presentation. Well, 5-minute video and 3-minute audio.
Pretty different.
Yeah.
Yeah. Yeah, it was definitely challenging for me too, because I guess I never realized like what you can actually fit in 3 minutes compared to like if we're just doing it for fun. But yeah, as you mentioned, one of the other assignments that we had to do in presentations was the podcast. So I was wondering what you did for your podcast, what topic you chose, and how you came to that decision.
So I chose the Ice Cube Neutrino Observatory at the South Pole. So basically it's a telescope that faces downwards.
Oh, wow, okay.
And so the thing with that is it's trying to detect neutrinos, which are these particles that travel at nearly the speed of light, and maybe one or two will react with you in your entire lifetime, but trillions pass through you every day without interacting with you at all.
Wow.
And
That's
so it's
pretty
really,
crazy.
really hard to detect them because they just pass through things. So what they did was they were like, okay, so we've got this giant blob of ice, Antarctica. And so they stuck a whole lot of Cherenkov radiation detectors, and Cherenkov radiation is a thing, it's a blue light that gets produced when you have a particle that travels faster than the speed of light through a material. So neutrinos travel faster than the speed of light in ice. And so they produce this Cherenkov radiation, which then gets picked up by the detectors. And that was something I learned about in my physics degree. And it sounds so incredibly fantastical. It sounds like it's not real.
Yeah.
That's why I chose it, because I really love writing sci-fi and fantasy. And so I actually turned the first half of my podcast, my first half of my 3-minute podcast, into a version of the IceCube reactor where I didn't actually use any scientific terms, and I acted as though it was this kind of fantasy idea.
Nice.
And I really had fun playing with that. And then I revealed in the second half, no, this is a real thing, and then gave some of the science behind it.
That sounds really cool, yeah. It's really good to see that you were able to combine like what you were learning and some of your interests into that as well. Was there anything that you found really challenging while creating that podcast?
Definitely keeping it short was something that was hard, because I know how fast I speak. I idle at about 151 words a minute. I know that from making YouTube videos. It was a weird statistic that I just calculated when I was making them. So I knew how many words I could use in the 3 minutes, but I kept on going over that word count that I knew I couldn't go over that, because I knew if I speak faster than 151 words a minute, I'm just going to start tripping over myself.
Yeah, fair enough.
But then another thing that I still struggle with is kind of when you're making videos, when you're making recordings, a lot of the time you worry, are people going to be able to understand me? Because obviously, being Australian, got an Australian accent, some people can't understand accents. And so a lot of the time I'm questioning myself a lot whether people are going to be able to understand what I'm saying. And I end up enunciating a bit too much. In particular, the thing that's really most noticeable is the letter T, really over pronouncing the letter T. And you got to kind of catch yourself when you're doing that. Just push it down and be like, talk normally.
Talk normally.
Don't over enunciate. Don't be like, and now I will open this bottle of water.
Of water. Yeah.
Where I'm going to over enunciate every T.
Yeah, I guess it gets pretty hard, like, when you start thinking about all the little details. Did you have, like, a specific target audience in mind when you were making your podcast that you wanted to make sure, like, you were accommodating to?
I did. I was thinking specifically of, science-interested people who specifically want to write science fiction.
Okay, cool.
Ideas for scientific things that you can include in science fiction, because the idea of it was a podcast series called Sounds Fantastical.
Sounds fantastical.
Where you start with like this 1.5 minute introduction that's kind of very fantasy.
Yep.
And then you have like an hour or two of people trying to figure out what it is and bringing in scientific concepts and being like, I wonder what it might be, and guessing. And then at the end, you actually say what it is and you give a spiel about the actual thing. But basically what I did was just the beginning and the end of what that would have been. Yeah.
Just like a little condensed version, kind of.
Yeah.
Yeah, nice. And kind of building up on that, were there any key takeaways that you wanted your listeners to take with them after listening to your podcast?
Key takeaways. I think a good key takeaway is to try to avoid repeating yourself in short communication as much as possible, because when you repeat yourself, you end up using up a huge amount of time.
Yeah.
And that really makes it very difficult to condense things into, like in the podcast, 3 minutes.
Yeah, for sure. So
yeah, that's really, really something to look out for.
Yeah, try to be effective with your words, kind of.
Mm-hmm.
Yeah, it's a good tip. So what's next for you in regards to SciComm? Are you planning to continue on this podcast series at any time?
Well, I don't know, because I've been applying for jobs. So if anyone listening to this podcast has any jobs for people who are, really good at writing creatively. But other than that, I've just been applying for jobs, trying to figure out what's next. So I honestly don't know.
Yeah, fair enough. Wish you the best of luck on the job search. And now we're going to play your podcast. So did you want to introduce your podcast a bit? Give a little introduction in?
I think I already gave a bit of an introduction.
Any last messages?
Any last messages? Have fun communicating science. Always have fun with it.
Deep beneath an icy land of endless day and night, the unseen races through the cold beyond the speed of light. At least, that's what the archives told them. But they had no way to know. No way to check for these invisible children of the stars who ride straight through worlds in their trillions, and yet rarely, if ever, touch. And so, for 7 years they worked long and hard, drilling 86 tunnels, each over 1,000 meters deep. And through each of those holes, they threaded 60 powerful machines, identical and yet each unique. Finally, it was complete. Thousands of machines buried deep beneath their feet. All that was left was to turn it on. And there it was, a flash of blue light. More years passed with millions of flashes of blue captured by the machines each day, bearing witness to the distant catastrophes that birthed this phantasmic frontier. And each day, as they detected more and more of those travelers that passed through the world itself, their predictions held strong. They were right all along. They should have been thrilled, and yet, in some strange way, being right was disappointing. Sounds fantastical, right? But it's actually all true. That was the story of the Ice Cube Neutrino Observatory at the South Pole. Neutrinos are subatomic particles that usually pass straight through everything, because they only interact through the weakest of the nuclear forces and gravity. They collide so little with other particles that 100 trillion neutrinos, that's one with 14 zeros after it, pass through your body every second. But on average, only one will interact with your body in your entire life. That's why the ice cube needs to be so big. It operates over an entire cubic kilometer to detect every neutrino interaction in that volume. It doesn't detect the interactions directly, though. On the rare occasions when neutrinos crash into something, they decay into charged particles called electrons, muons, and taus. These particles travel through the Antarctic ice faster than the speed of light, which causes them to emit photons of blue light called Cherenkov radiation, which is the same as the blue glow you can see from nuclear reactors submerged in water. Using this radiation, scientists can calculate what directions the neutrinos came from and how energetic they were. This data helps us understand where and when the cataclysmic events that produce high-energy neutrinos are happening throughout our galaxy.
Thank you so much, Keelan. See you.
Thank you.
Thanks for listening. Find us online at thescicommcollective.com. That's com with 2 M's. Questions or comments about today's episode? Get in touch on Instagram at the SciComm Collective. The SciComm Collective is supported by UWA's Grand Challenges Impact Grant.